All right, I consider this to be a difficult question, by the way, and someone says, how would you do it? Kind of looking at it, and, test for divergence is really not going to be helpful. You might want to say, maybe I could do the integral test on it because of the positive term. You know what? I'm going to try to do the integral test on it. I realize something else is written over here, but let me write this one down for you. And I'll write down, two, by the way, I'm going to say this is a continuous positive decreasing series. So I'm going to do the integral test on it and see if that works out. And maybe it doesn't, I don't know. So let's see, ln x, and this would be ln x. And then you get, dx over here. I probably would say u is equal to ln x. And du would be 1 over x. That's not going to work, is it? So I was hoping that something would happen, but nothing's really happening over there. Again, you might say, so you give up too easily. Maybe. So what I want to do is I want to go through, I got to start looking at this, and maybe it's not as easy as it looks, and I'll put this over here. So the first thing I did was I kind of wrote down this thing, and I kept rewriting it until I saw something that looks somewhat familiar to me, right? So what I do, I wrote, the natural log of n down as, e to the natural log of the natural log of n. And, I did, maybe little exponent rule tricks, commuting those things around. What I mean by that, I commuted these two around over here. Yeah, not so bad. And then I kind of looked at it, and e to the ln n is n. So this thing over here is really just equivalent to this thing over here, all right? The next thing I did, which I'll be honest with you, is not the simplest thing in the world to do, is to kind of look at this thing over here and realize I just simplified the bottom. That's all I've done. I'll write that down for you. So this over here is equivalent to n equals 2 to infinity, 1 over n to some power. And what's that power? It's the natural log of the natural log of n. That's even confusing to write down. So then the problem comes is, what are you going to do over here? I look for a comparison. All right. The comparison I looked for was something that I felt I could figure out, and so what I tried to figure out was, a comparison, and the comparison I came up with for this thing over here is this over here. All right. So what I need to do is I'm going to say for when n is that true, and this required some playing around, by the way. It also required me using a computer, to be honest with you. I wasn't going to do so. You get tired and stuff. You start to say, gee, I need to use a computer to do that. So the bottom line is there's two things I need to do on a computer. I need to show that this thing is greater than 2, all right, which means the left-hand side, I could probably look at that and say just that exponent looks like it's greater than 2. And, for all n, greater than 16, 18, it took computer power to do that. The next thing I noticed that this conversion P series, all right? And by comparison test, what I got, well, this is convergent. By comparison, this would be convergent. End of story. Thank you.